Weatherford International has been a dedicated industry leader in the re-entry market for over 3 decades. This commitment to technology development has enabled operators to maximise the full potential of their mature assets, or previously uneconomical behind-pipe reserves. This operational overview of a casing exit installation clearly highlights Weatherford's answer to the industry, providing technology that is effective, efficient, and economical. In any casing exit installation, the wellbore needs to be properly prepared, utilising a bottom hole assembly to scrape clean the casing wall and simulate the subsequent bottom hole assemblies qualifying the casing inside diameter. The secondary feature is circulation of the work string and wellbore fluids to displace any debris or contaminants that could interfere with events during the installation sequence. Combining the whipstock simulation assembly and debris removal method together removes the unnecessary risk or unknowns between the rig floor and target setting depth for wellbore departure. The wellbore preparation assembly is lowered into the wellbore, scraping and gauging the casing inside diameter while removing any unknown anomalies. If debris is encountered, the assembly is picked up, pumps engaged for circulation and rotation of the string is started. The work string is then lowered, allowing the assembly to pass through the debris while cleaning and scraping to a predetermined depth just below the target installation depth. Once the entire target area has been prepared for the whipstock installation, circulation of the wellbore fluids continues until there is no more evidence of debris in the returned fluids at surface. The wellbore preparation assembly is now removed from the well for visual inspection and measured for gauge wear. With a false bottom in place, the quick-cut casing exit system with mechanical multi-catch anchor is assembled and tripped into the wellbore to a depth just above a bridge plug or false bottom, required for the actuation of a mechanical bottom trip anchor. The complete work string is then reciprocated in an up and down motion to remove any torque that became trapped into the work string during the tripping process. Once the work string is stationary, the pump is engaged and the flow rate increased to the predetermined output required, sending an MWD fluid pulse signal to surface, providing the current direction of the whipstock face. If the whipstock face and departure direction correlate, the work string is lowered slowly to the plug depth. Once the bottom of the anchor contacts the bridge plug, a predetermined set-down force is applied. This force shears the machine screws in the anchor. A compression spring force is instantly released, driving the slip body up, biting the slips into the casing wall. Using additional set-down force will continue to wedge the anchor slips into the casing while creating a fulcrum effect to securely anchor the whipstock assembly. The whipstock assembly is now firmly anchored against the casing wall, independent of the bridge plug or false bottom. This anchor works in a wide range of casing sizes and weights, ensuring good contact even in adverse conditions. With the whipstock assembly firmly anchored, the quick-cut milling assembly is released by applying a downward force onto the anchored assembly to overcome the predetermined shear value of the attachment screw. This shearing event alerts that the milling assembly is disconnected and can be lifted to a safe distance above the whipstock top to capture all the desired pre-milling parameters. The work string is lowered until the lead mill engages the top of the whipstock assembly. The rotary torque will increase as initial contact is made, but remain constant as the load is applied to maintain a consistent rate of penetration. The quick-cut milling assembly will then track the trajectory of the whipstock radius, removing casing material, cement and formation to achieve the required depth for drilling operations. Once TD is achieved, the milling parameters are reduced, and the milling assembly is hoisted above the window created in the casing. The milling assembly is then reciprocated slowly throughout the casing window to profile, polish and condition the entire area prior to receiving the next BHA assembly. The quick-cut milling assembly is now removed from the wellbore to receive final visual inspection and be measured for gauge wear.